What if I told you there was a bug bigger than you are? 9 feet long, wider across than your shoulders, heavy as a grown adult, and its relatives are still alive today, probably one under a rock in your backyard right now. This is Arthropleura, the biggest bug that ever walked the earth. Arthropleura was a myriapod, the group millipedes and centipedes belong to, which means technically not an insect. I know what the title says. Insect just sounds better than bug, and now you know the difference, that's on the house. And for 170 years, nobody could tell you which of those two it actually was. Millipede or centipede. Those are not small options. Millipedes eat leaves. They're harmless. You've picked one up. Centipedes, on the other hand, are venomous predators. So which was this? 9 feet of harmless leaf eater or 9 feet of the largest venomous predator ever to walk a forest floor? For 170 years, we couldn't answer that. And the reason why is one of the strangest stories in paleontology. It took 2 babies and a CT scanner. Arthropleura lived between roughly 346 and 293 million years ago, a stretch of time called the Carboniferous, running into the very start of the Permian. If those names mean nothing to you, don't worry. All you need to know is that this is over 100 million years before the first dinosaur. So, when you picture the world this thing walked through, forget everything you know. No birds, no mammals, no flowering plants. Just dense, humid forests of giant ferns and tree-sized mosses sitting on top of the swamps that would eventually get squashed into all the coal we dig up today. And this was the age of giant bugs. You've probably heard of some of them. Griffin flies, dragonfly relatives with wingspans over 2 feet. The largest flying insects that have ever existed. Pulmonoscorpius, a scorpion about the length of your forearm, hunting the forest floor in what's now Scotland. Those are the famous ones. The poster children for prehistoric bugs getting out of hand, and not one of them came close to Arthropleura. The biggest land arthropod alive today is the coconut crab, and it barely clears 3 feet leg to leg. Arthropleura was 3 times that. If one walked into your room right now, it wouldn't fit. So, the obvious question, what does something that size eat? For a long time, the honest answer was, we were guessing. And the reason for that is where this whole story turns. There was one promising clue. In a specimen found in Scotland, researchers spotted plant material, fern spores, bits of club moss, sitting right about where the gut should be. And they found droppings. Fossilized poop, which has an actual scientific name, coprolites. Those were packed with plant debris, too. Case closed, right? Plants in the gut, plants in the poop. It ate plants, except it didn't hold up. When people took a second look, they realized the plant material might not have been inside anything. It may have just settled next to the fossil and gotten preserved alongside it. Just debris on a forest floor that happened to fossilize in the same rock. The evidence got downgraded to inconclusive. And some researchers pushed back harder than that, arguing that nothing gets to 9 feet on a diet of dead leaves, and that this animal must have been eating other creatures. Invertebrates, maybe even small amphibians. So the question stayed open. Gentle giant, or the biggest predator on the forest floor? To settle that, you'd need to look at its mouth, and that's exactly what nobody could do. Arthropleura was first described in 1854 from fossils dug out of coal country in southwestern Germany. And from the very beginning, there was a problem. None of the fossils had a head, not one, not a partial, nothing. Which meant that for 170 years, every drawing, every museum model, every reconstruction of this animal was a headless guess. We knew the body, we knew the armor, we had no idea what its face looked like, and without the face, we couldn't settle what it ate or what it even was. Now, there are 2 reasons the head kept going missing, and the second one is my favorite fact in this entire video. The first is molting. Like modern bugs, Arthropleura grew by shedding its shell, crawling out of the old one, and leaving it behind. And when a myriapod sheds, the shell splits open right at the head. So most Arthropleura fossils aren't bodies at all. They're empty suits of armor. The helmet pops off and the animal walks away. That's reason one. Here's reason two. For over a century, researchers thought they did have the head. There's a plate at the front of the body, and it looked the part, and it got labeled as the head in study after study. It wasn't the head. It's called the column, basically the animal's neck plate, the first segment of the body. And the real head sits tucked up underneath it, mostly hidden. So it's not just that we couldn't find the face. We'd been staring at the wrong part of the animal and calling it a face. Now, here's how it finally broke. Back in the 1970s, a coal mine in Monceau-les-Mines, in France, turned up a batch of round stone nodules, lumps of rock with fossils sealed inside them. They went into the collection at a museum in autumn and sat there for decades. And they sat there for a good reason. The only way to see inside a nodule used to be to crack it open and take a cast of whatever was in there, which works, but you get one shot, and delicate things get destroyed. Then scanning technology caught up. In 2024, a team ran those nodules through micro-CT and synchrotron imaging, essentially a very high-resolution X-ray that builds a 3D model of what's inside a rock without ever opening it. Two specimens stood out, and they were tiny, 25 and 40 millimeters, about an inch and a half, small enough to sit on your fingertip. Babies. Or at least juveniles, young ones that hadn't finished growing. And they had something no Arthropleura fossil had ever had. One of them had a complete intact head, and after 170 years of guessing, a face came up on the screen. Antennae, jaws, mouth parts, and something nobody expected. Eye stalks, like a crab, eyes sticking out from the sides of the head on the little stalks. Nothing alive in the millipede or centipede world has those. And it hints at something odd about how this animal grew up. The young may have been amphibious, spending their early life in water before moving on to land for good. So, millipede or centipede? Predator or not? Start with the body, because that part was never really in doubt. Arthropleura has 2 pairs of legs on every body segment. That's called diplosegmentation, and it's the defining millipede trait. Centipedes get 1 pair per segment. Millipedes get 2. But the face didn't match the body. The jaws are laid out like a centipede's. And I know how that sounds. Centipede mouth, so predator. Here's the thing, though. What actually makes a centipede dangerous isn't its jaws. It's a separate pair of venom claws sitting right behind the head, called forcipules. They're modified front legs that grab prey and inject venom into it. That's the murder equipment. Arthropleura doesn't have them. No venom claws, no fangs, nothing anywhere on the body built for catching anything. Just small mouth parts suited to grinding up plant matter. And the trackways back that up, the footprint fossils show a slow, lumbering walk. Not the movement of something that chases things down. So, harmless leaf eater, or the largest venomous predator ever to walk a forest floor? It was the leaf eater. The scary face came with none of the equipment, which finally settles the diet question that the coprolites couldn't. Not because we found better poop, because we found the mouth. And where does that leave it on the family tree? The researchers put Arthropleura on the millipede branch, but off to the side, close to millipedes, sharing features with centipedes, sitting near the point where those 2 groups split apart. 170 years without a face. We finally get one, and it settles the argument. But the body was still doing something no centipede has ever done. 2 pairs of legs per segment, and somewhere around 30 segments. Do that math, and you land somewhere north of 100 legs. The honest answer is that nobody's certain. Different specimens preserve different counts, and published estimates don't agree, anywhere from a few dozen pairs to well over 100 legs, depending on which fossil you're working from. But the number matters less than the picture. Whatever the exact count, this was an animal moving on wave after wave of legs, firing in sequence down 9 feet of body. And that's not just something to imagine. It's something this thing left behind. Arthropleura remains have turned up across about 60 sites in 13 countries. North America, Europe, the UK. But the most common evidence of this animal isn't its shells. It isn't its bodies. It's footprints. Trackways up to 50 centimeters wide, nearly 2 feet across, pressed into ancient mud and turned to stone. And there are more of those than there are body fossils. Think about what that means. We have more evidence of where this thing walked than we have of the thing itself. Enormous trails leading off across a forest floor and almost nothing at the end of them. Which is exactly what makes the next part absurd. January 2018, Howick Bay, Northumberland, on the northeast coast of England. A block of sandstone breaks off a cliff and falls onto the beach. It cracks open when it lands, and a former Cambridge student out walking the coast happens to look down at what's inside it. Arthropleura, only the third fossil of its kind ever found, and the largest anyone has ever recovered. Dr. Neil Davies of Cambridge, who led the study on it, called it a complete fluke. And he's right. Nobody excavated this. Nobody surveyed for it. A rock fell over, split at exactly the right angle, and somebody walked past at the right moment. The piece itself is about 75 centimeters long, 2.5 feet, and it's only a fragment. A shed chunk of shell that got buried in an old river channel and filled with sand. From that fragment, the full animal comes out at roughly 2.7 meters and 50 kilograms. 9 feet, 110 pounds, from a rock that fell off a cliff. But the size isn't the most important thing about that fossil, it's the age. Here's the explanation you've probably heard for why bugs got so big back then. The reason was oxygen. Bugs don't have lungs. Air seeps into their bodies on its own, so the more oxygen there is in the atmosphere, the more of it reaches their insides. And carboniferous air was rich. Today we're at about 21% oxygen. Back then it climbed past 30%. So, more oxygen, bigger bugs. Clean, intuitive, and it's in basically every documentary ever made about this period. Most Arthropleura fossils come from that late oxygen-rich window. The Howick fossil doesn't. It's about 326 million years old, older than the rest, and it comes from a stretch when oxygen was sitting around 23%. Barely above today, meaning the largest Arthropleura we have ever found was already enormous before the atmosphere gave it any reason to be. The textbook answer for why this animal got so big might just be wrong, and right now, nobody has a replacement for it. I've got a theory of my own. Comment down below what yours is so we can see what everyone thinks. Here's where I land. Remember those eye stalks? The crab-like ones on the juveniles? The hint that the young may have started out in water. Water carries weight. A growing animal doesn't fight gravity the same way in it. So my hunch is these things got a running start on size before they ever came onto land, and once they were out here, they just kept it. Which brings us to the part nobody has answered. I said a minute ago that bugs don't have lungs. Here's what they have instead. Openings along the sides of the body leading into a network of tubes that branch deeper and deeper until they reach the tissue directly. Air moves down those tubes on its own. Nothing pumps it. It moves because there's more oxygen out here than in there, and that difference pulls it inward. That works beautifully when you're small, but it falls apart fast because seeping is slow. Double the distance and it takes about 4 times as long. So the thicker the animal, the deeper the air has to travel, and eventually you hit a wall. Oxygen physically cannot reach the middle of the body fast enough to keep it alive. That's the real reason insects are small. Not evolution's choice. Physics. The plumbing runs out. Arthropleura was 22 inches wide, 9 feet long, 110 pounds. Running on a system that, as far as we understand it, should not have been able to keep an animal that size breathing. And we don't know how it did. That isn't me simplifying for the video, it's a genuine, open problem. The biggest land invertebrate in the history of this planet, and one of the most basic questions about how it stayed alive is still unanswered. So how does something that spent more than 50 million years as one of the largest animals on land just disappear? There's no good story here. And that's what makes it worth telling. There was no asteroid, no eruption, and no single catastrophic day. What happened was that the world dried out. Those dense, humid, endlessly rotting forests that covered the equator started breaking apart. The climate shifted. The rainforest split into isolated patches, and the thick carpet of decaying plant matter that fed this animal stopped being everywhere. And it wasn't just Arthropleura, that whole cast of giants goes with it. The griffin flies, the oversized scorpions. An entire era of enormous bugs thins out and vanishes as the conditions that allowed them quietly stop existing. Arthropleura doesn't die out in a moment, it just appears in fewer places, then fewer, then it stops appearing at all. 50 million years of being the biggest thing walking, and it ends without anything happening. So let's sum all this up. We found the first pieces of this animal in 1854 in a German coal mine. For over a century, we labeled the wrong body part as its head. We didn't see its real face until 2024, and when we finally did, it came from a baby the size of your fingertip that had been sitting in a museum drawer since the 70s. We thought it was a predator. It wasn't. We thought we knew what it ate. That evidence fell apart. We thought oxygen explained its size. The oldest fossil we have says otherwise. The best specimen in the world exists because a rock fell off a cliff and somebody happened to walk past it. There are more of its footprints out there than there are of its bodies, and we still can't explain how it breathed. 170 years of studying the biggest bug that ever lived, and it's still not done giving things up. That's it for this one. Thanks for sticking around to the end, genuinely. If you want more of this kind of thing, subscribe and tell me what you want covered next. Thank you for listening to the Fossil Archives.